Oh, so we at Adaptavate are material developers. We are material developers with a difference. So what I set Adaptavate up to do is to rethink how material flows in the built environment work. It's very simple, really. 4 or 5 years later. So we think about material flows in the construction sector as let's grow the materials of the future. Okay? And what I mean by that is let's think differently about this. Let's positively disrupt the material flows. Instead of it being take, make, waste in a very linear, wasteful, sort of non-resource conscious way, let's think about ways in which we can grow renewable capital year on year. How they could be put into high-performing materials that can save you energy and improve the health of your homes, and at the end of their life, they are in fact used as nutrients to grow more renewable capital, not pollutants. So let's bring this thing full circle. But most importantly, let's just think about it in terms of, let's think about the premise that that is a good thing to do. Let's make that assumption that that is a good thing to do. Well, if we want to do that, and it's an impact-driven business, this is a business that can be a force for good, then we need to have mainstream materials. And they need to be made on mainstream processes. Because then, people like you and I that are sat in this room today can really kind of, witness the benefits of these things. So, we have two products at the moment. One is on the market, called Breather Plaster, and one is Breather Plaster is an internal plaster system, and Breather Board, which is a direct alternative to plasterboard. Shh. They are both compatible drop-in alternatives to the incumbents in the market. So that means that any tradesmen or women that are in the industry, or anybody that specifies products, or anyone that uses products, they can use these materials just like they would the rest of the other materials that they use in the industry so commonly. These can be used together, and they can be used separately. And it's also should go to say is that Breather Board is not currently on the market, but we are working hard to bring it to market. So my story starts on a building site. I used to be a builder, and I worked actually for Alex for some strange reason for a little bit, and unfortunately got out of it, so that's good. But I started on site renovating buildings, trying to affect buildings with my hands, one by one. And what I tried to do is make that building that I was working on the best building I could kind of have an effect on. And what I wanted to do was sort of have a bit more, think about this in a different way. So I went and studied a master's in sustainable architecture at the Centre for Alternative Technology, who have a stand around here, and anyone that's wanting to become educated into sustainable architectural practices, I suggest you go and have a word with them. They have some very flexible courses and produce some very capable and game-changing people that are, in the industry. So they're just behind here in this wonderful area just behind us. But what I did there is, through the thesis, is that my thesis is that I wanted to develop a composite that could be used instead of plasterboard. So I spent however many months testing, iterating, and trying to develop composites that could be used as alternative to plasterboard. I gave myself a very tight design specification because this was driven by impact. At the fundamental core of all I was thinking about was ecological sustainability, ecological consciousness. I read a book by Yvon Chouinard, who is the founder of Patagonia, Businesses Can Do Good, and let's lead by example. So that is an underpinning thing that sits underneath all of our work. But for our materials to have the widest uptake in the market, to have the widest benefit, they needed to do these things. It most importantly needed to meet standards, because if you can't meet standards, then you can't get them into mainstream market. Alongside that, really, is that the solution, as I said, had to be able to be used by the guys and the girls on site, or the people specifying it, or you know, those people using it, okay? That's really important, because if you get your product to site and it needs retraining, you've then got a bit of a challenge there. And Roland's done some great work around standardizing earth and how you can really standardize that for people to work with it. But let's try and think about these material offerings that try and minimize the barriers to market. What we also said was that they need to be renewable and compostable, as I just shared with you earlier. And that was really important, because that's the whole circular notion of the business model. Then they have to have this performance thing. So that's the reason why someone would specify it in use, or that's the reason why you would want it on the walls in your building. And that's where the health benefits come from. And then, of course, there's weight. Weight is really not so much of a big issue here. It's only about installability and how easy it is to lift the product onto the wall or whatever. In America and Canada, where there's a big market for our product, and we're growing into, weight is massive from distribution. So that's quite an interesting, if you can save weight on product, that has a big distribution cost. So the problem I was trying to really solve was this, and the gents here have spoken about it, and I'm sure I'm preaching to the choir, as it were, or the converted, whatever that phrase is. But you know, if you know, energy efficiency of buildings is trying to be addressed, which it is, and then it's not, and then it is, and then it's not, depending on which way the wind blows. But you know, let's just take it as it is. That, you know, we need to increase the air tightness of the building, increase the thermal fabric of it. Okay. Well, the problem is that you and I and our families and our friends all produce moisture. We were born with that ability, and it's about 14 litres of moisture a day an average family gives off. Now, if it's an airtight building that's quite warm, where is it going? Well, then we have to rely on some methods to be able to then regulate that moisture. If we don't do that, then mold builds up, and I'm sure we've all seen problems with that. So, you know, that's a problem, and it's an increasing problem, and it leads to asthmatics, and there's a lot of them in the UK, and there's even more of them around the world. And we've already heard, well, it's between 80 or 90% of our time indoors. It's something like that. It depends on where you live and how you live your life, but we spend an awful lot of time indoors. On top of that, it's not just about moisture, it's about these VOCs, volatile organic compounds, and they're the things that make you feel a bit poorly, and they can also give you things like cancer, and they're not very good. And actually, in the news, we hear a lot of stuff about outdoor air quality, and in cities such as the one that we're sitting in at the moment, you know, the outdoor air quality is very bad, and that's very bad. The challenge is actually in your lounge, or your, as you said, your kid's bedroom or whatever, the pollutants can actually be 10 times that concentration than in a city centre. Mind-boggling, isn't it? So, if we spend all this time in these buildings, then we best create some buildings that are good for us. There's another kind of global, if we take a step back for a second and kind of, you know, pull our heads out of a building, actually, if we just look at health on a broader philosophical level of an Earth's health, we're putting stuff into holes in the ground, the holes in the ground are filling up, and people are now charging us to put stuff in holes in the ground. And construction as an industry, we're quite wasteful. So that's a challenge. And plasterboard is like 240 quid a tonne to get rid of now, depending on who you are and where it is and all that sort of thing. That's in the UK. Health, again, the world's health, we're using finite resources. Finite means it runs out. Now, that's a challenge because, well, we've got you know, growing population and a global demand, an increasing demand for products. So how are we going to think about this in the future? Well, for me, that's a commercial opportunity, and it's a health opportunity for us. So what we do is we use biomaterials. What we do is we take wastes and byproducts from the agricultural industry, straws and whatnot, and we put them into our products. And what that does is it displaces the kind of finite materials, but it also gives them some really cool benefits. And some of them are what the gents have said already today, so I'm not going to go over them all in great detail again. But biomaterials can actually give you good thermal performance, saves you energy, good. They're lighter materials. We spoke about the benefits there earlier. The lungs to breathe. We've spoken about moisture buffering and how materials can sort of absorb and desorb. Well, the biomaterials, this stuff, is like got capillaries like your lungs, but instead of it for oxygen, it has the ability to absorb and desorb moisture, and that's really good, and we'll come on to that in a bit more detail. They're renewable and they're compostable, so that's good. That's disrupting the material flows, as we said, But what's really cool, and the way in which you can have the most impact, is about how these waste streams can have international applicability. In the UK, we can use a certain types of feedstock, but where our business kind of vision and impact can come from is working with you in Canada and with you in the Middle East and with you guys over in Australasia, you know, and you all have different feedstocks that are abundant in your areas. Well, what we do is we characterize these and we can put them into products that are relating to your territories, and that's how you can have widespread sort of disruption. So, breather plaster has been used on some very cool projects recently. It has benefits in terms of absorbing and desorbing moisture. It's quick setting, so it was designed to be, having come from a building background, you know, it needs to be quick setting like the rest of the plasters on the market, so that anyone can pick it up. They put the first set on, go for a brew, come back, put your second set on, and then go for another brew. That's what tends to happen. And then you come back and you trowel it all up and you're done. Okay, but it has all the benefits of the gents have been talking about this morning. This is the Conduit, which is a very sustainable members club in Mayfair. They used all very pioneering environmental technologies. And some of our merchants are here, Celtic. We've got Eco Merchant over here. And then we've also got Mr. De La Roy from Holland, who's bringing our product into the Dutch market. Breather plaster, if I just sort of demonstrate how these materials, we spoke about moisture buffering. Well, the material, as Roland says, when you're creating moisture, it has lungs to absorb it, and then when you go to work or you go to sleep, it desorbs it back into the environment, and that reduces energy, and that reduces problems with mold and condensation. It's mental how much moisture we produce, and this is, you know, it's a really bad graphic, sorry about that, but these are passive materials. They call them passive, natural, healthy materials. Actually, the materials are more active than our sort of synthetic materials. Dun, dun, dun. Philosophical debate in the pub. But it's not just about health, it can also be about energy and cost saving. Whilst, yes, these materials may be more costly in upfront costs. Upfront costs of materials in building can only be 20 or 30%. Okay, it's your labour that your cost is the majority quite often. But if you think about the alternatives of maintaining a healthy environment in the building, there's things such as fans, and they cost to run them, and they cost to install them, and they have costs of maintenance, and for tenanted properties that's a bit of a nightmare. So as these passive natural materials can be sat on your wall, bought from a normal merchant, they can actually be saving you on significant ongoing costs. And we're talking at the National Landlords Association this evening, my commercial director, this evening, about the cost savings there specifically. This is another slide about that. I'm going to finish with one last point, really. One last point before our three last points. But you know, plasters on solid walls, if we were to upgrade the thermal fabric of the buildings that are, you know, old school solid wall buildings, just 8 mil of breather plaster can raise the temperature of the wall 4%. 4 degrees Celsius, sorry. Now that's the difference between moisture condensating on the wall due to it being a cold surface and it not condensating. And then it has all these breathability benefits. So it really does have quite an impact on your building, the health of your building, and the health of the people in your building. And there are a great array of materials. I'm extolling, you know, the virtues of some materials that I've dreamt up, but there are hundreds of them around the corner from here, and very passionate, knowledgeable people. So if this is of interest to you, I really do recommend you go and speak to them. I've got 3 cosmic conclusions just to finish with before open the floor up for questions. Materials can act as passive regulators in buildings. That's without you having to switch them on. That was wicked imagery from Roland. But they can help improve your health and energy performance just by sat there. The key to having a widespread impact is having drop-in mainstreamable solutions, and that's where we're focused on. And the ecological broader impact is a sort of underlying fundamental principle on which we should be acting and approaching, because there is a significant opportunity in that space. I hope you all have a lovely day and learn lots of nice new things and see lots of new products, and thank you very much.